Okay, hello all you crazy people out there. My name is Michael, I like wizards and dragons and making games, and welcome back to the wonderful, wonderful world of shaders. In the last video, I did an overview of what shaders are, what the data types are, the things you can do with the data types, and we successfully turned this little yellow duckling sprite upside down and colored him red. And in this video, we're going to make him a little bit more alive. So this is the same project I have at the end of the last video. There is the Vertex Shader, which I ultimately didn't change anything in, except for the stupid curly brace that was on the line below function definition that I don't like because that annoys me. And in the Fragment Shader, I inverted the Y coordinate of the texture coordinates and removed the green and blue color values. So let's talk about uniforms. So uniforms, as I said at the end of the last video, are a special type of variable that are used for passing information to the shader. They're essentially parameters for the shader. You can think of them that way. And you define one. That is, okay. There's a space in the middle of that word. You define them with a uniform before the type. I'm going to make this a float. And I'm going to call it time. So I'm going to start by having a simple uniform representing time. And we are going to make the little duckling change color over time. This is the Fragment Shader, by the way. I hope you can all see that because it says that at the top, but just in case you need that in an audio form, this is the Fragment Shader. So you can do math in shaders. In fact, you can do quite a lot of math in shaders. There's a few things you can do. I'm going to start with a sine function. Sine is a wave. I'm going to, let's see. If you ever need to visualize something that's going on in a shader, especially with sine or cosine or something like that, the Desmos online graphing calculator is amazing. So we're going to just say the function of x is the sine of x. If you do anything with games, sine and cosine are your best friends. Right now I'm using it for graphics for shaders, as you can see. You can also use them a lot for movement, certain stat equations perhaps. If you've never taken a trigonometry class before, this is a sine wave. You can see it oscillates between +1 and -1. And that's what I'm going to be doing here. I would like this duckling to flash red, so we're going to have the green and blue color channels oscillate between -1 and +1. So I'll run this, but this is going to not exactly be a nice oscillation, and nothing is happening at all because I forgot to actually set the value of the uniform. Let's go shader set uniform F, and let me make this a little bit bigger because I'm worrying about the draw code right now. The uniform ID is going to be an index. So you can say shader get uniform, and that will get a reference to a uniform that you defined in the shader. In my case, that is the time uniform in the shader demo shader. And that reference gets saved to a variable. And you can pass it into the shader set uniform function and its value. For its value, I'm just going to say current time. And the built-in variable current_time is the number of milliseconds that has passed since the game has started. 1 millisecond being 1/1000th of a second. So if I want to translate that into just seconds, let's divide that by 1,000. If you want, instead of saving the uniform reference to a variable, you can just pass it in to the set uniform function directly. It's not something that will save you any reasonable amount of time, and it can make your code harder to read, so it's probably something you should avoid doing. But now let's run the game. So I've set the uniform, and now the thing is gonna flash colors. Now it's gonna oscillate. So you can see it's flashing between red and after a period of time, it'll go to a kind of bluish white. So there's a couple things going on here. I guess I should say up front that this isn't exactly what we want, if you have not deduced that already. If you were to simply set, yeah. No, help. If you were to simply set these color values to 1.0, you can also, and I meant to mention this in the last video, you can just say 1 dot without a 0, and it will work. That's not something that you're allowed to get away with in most normal CPU programming languages like GML or JavaScript or C or anything like that. But in shader languages, just saying a number followed by a dot without a actual decimal part will indicate that it's supposed to be a floating point number instead of a integer.
Hey.
So dialing up the blue and green on these colors, it will make all the pictures approach white. So instead of setting the green and blue equal to the sine of the time, we want to instead say color.g times the sine of the time, the sine of the time. There's a pun in there somewhere. I'm not going to spend energy figuring out what it is. And this will make instead of fading to a weird bluish white, it will make the duckling fade between red and its original color. You can imagine looking at the sine function if I were to come back to the sine function, if the original value of for example, green value of a pixel is 0.5, the sine wave will instead oscillate between its original value and the negative version of its original value. So that's the amplitude of the sine wave. I'm hesitant to say that taking a trigonometry class is a prerequisite for doing this kind of thing, but it certainly does help. I would like to spend a minimal amount of time talking about trigonometry here. If you want to shorten this, you can, of course, say, oops, instead of saying color.g equals color.g, you are allowed to say times equals, as you are in most programming languages, and that will do the same thing. Okay, so you'll notice there's a period of about 3 seconds in here where the duckling stays red instead of bouncing back. That's because of the negative part. As I mentioned in the last video, a negative color value doesn't really mean anything. Most of the time it's fine. Most of the time it'll just assume 0 if you have a negative color value. It's not really a safe thing to do. You probably want to use a clamp function or something like a max function for the value of the sine and 0. And that will ensure that the color value never goes below 0. That will do the same thing. It's considered correct to check those things. However, if we want it to flash continuously instead of pausing, we can do a little bit more manipulation on the sine wave. So if we want this value to have a range of 0 to 1 instead of negative 1 to positive 1 or negative 0.5 to positive 0.5, we can instead say 0.5 times the sine of x plus 0.5. I want a space in between there because I want my code to look pretty, dang it. And now the sine wave is varying between 1 and 0, or 0 and 1. I guess I'll leave the max function there. Anyway, we can implement that in here. Obviously, you don't need to refer to the online graphing calculator to do this, but it does help visualize the values on a graph if you're ever going to do something like that. It pauses when I click on the bar around the window. That's interesting. The game is kind of sort of paused when you do that, and I should probably remember to not do that if I have shaders running that have a continuous value over time or something. Okay, I guess while I'm talking about trigonometry, if you want it to flash faster, again, if you've taken a trigonometry class, you know where this is going. You can mess with the period of the wave by multiplying the parameter inside the sine function by a value if you want it to go absolutely bonkers. So let's multiply green and blue by 10. And that needs to be either 10.0 or just 10 point, indicate that it's a floating point number because, again, types. Now it's going faster. Let's have it do like a rave or something. Yeah, that sounds about right. Don't look at that for too long. I don't want to be responsible for anybody who has a photosensitive condition. I think something like a multiple of 5 should be good. Okay. The exact period of a sine function is 2 pi, by the way. So if I just have sine of time, the amount of time it'll take to go from its regular value through a complete cycle of red and back is going to be 2 pi seconds, or about 6.28. Multiplying that by 5 will make it What's 6.28 divided by 5? By 5, about 1.2 and change. Just a little bit of math to think about. Like I said, I don't want to get hung up on too much more trigonometry here. If you want it to vary more, you can always mess with the equations. So that's we're kind of doing a hue shift here. The sprite is getting progressively greener and more magenta instead of red and yellow. If you wanted to give it a slight offset, you could do that also. That's not really noticeable. I won't do that. So you can also, this is the Fragment Shader as established, but you can also do this in the Vertex Shader. So if I were to comment this out, I could do the same thing in the Vertex Shader. You can assign uniforms in the Vertex Shader. And you have most of the same things that you did before. You have color values, you have texture coordinates, those are being passed to the Fragment Shader. You have the position in space. I could mess with the color value again, but I don't really want to. Let's instead mess with the position in space. Yeah, okay. Let's say the position.x plus equals the sine of time. And we'll do the same thing with y for now. This is going to be not very noticeable at all, if any, because it's just oscillating by 1 pixel on the screen. If I were to come back to the graphing calculator, let's make this just like 1. Let's give it its regular period too. You can amplify this. You can say 25 times the sine, and now it's going to vary between -25 and +25. So let's implement that change in the Vertex Shader, and now the sprite is going to be not moving on the screen. Okay, that is not actually the value that I want to manipulate. Let's let's mess with the original position instead. That is going to be that. And instead of setting the object space position equal to the in position, let's make it. Do I want to do? All right. Well, I've already mentioned swizzling with vectors.
Hey.
Which again is the best technical name in all of computer science. I'm allowed to do that. So now the duckling's position is oscillating back and forth on both the x and the y axis, according to time. If I wanted to speed that up a little bit, we could change the period. If I wanted to make it go diagonally the other way, I could invert one of those, and now it's going upper right and lower left instead of upper left and lower right. If I did want to mess with color, you could say let's mess with transparency this time. What was the equation I had before? 0.5 times that. I'll just copy the whole thing, and we'll times equal it. Actually, no, that's fine. That's fine the way it is. And lines must end in semicolons, otherwise the shader compiler will complain and it will have a very unhelpful error message. That's not working. Oh, right. I need to actually use that color value, otherwise it's just a value that's sitting there and not doing anything. Oh, okay, hang on. I forgot I took that out. The color isn't actually being used by the Fragment Shader. God, you'd almost think I'd script these videos or something. So now the duckling is fading in and out. He's just having the time of his life up there, hanging upside down, swinging back and forth, fading in and out of existence. That's how I like to spend my Saturdays too. So that's the basis of uniforms, of uniform values. You can see, you know what, just for fun, I'm going to re-enable this. And I also need to uncomment the time uniform. So just for fun, I'm going to have you fade to red and to not red, and that's on the same period as the transparency, so you can't really see it. Don't get hung up on this, he says, and then he does exactly that. Alright, that's not as noticeable as I was hoping it would be. So maybe using this for something that's a little bit more useful, although now that I think about it, this does have its uses. Glowing objects fading to a color. If you want a glowing object to draw the player's attention towards something, you can do something like this. Color correction. I'm going to, let's comment that out. Let's also comment this out, so the duckling is going to sit still. Let's go back over to the Fragment Shader. Let's define another uniform, which is going to be brightness. Let's yank this sideways into a brightness and contrast shader or something like that. Or at least brightness, because I don't really feel like doing contrast right now. Contrast would be similar to what I'm going to do, but the math behind it would be a bit different. So instead of time, I don't really need the time uniform there anymore, but I guess I can keep there because it's not hurting anything. Let's set the uniform to brightness. Like that. And this is going to be just a scale factor that the color is multiplied by. All brightness is, and a fun little coincidence that you might be interested in is right before I sat down to record these shader videos, someone posted on the GameMaker Reddit asking about how brightness works and stuff. So that's fresh on my mind. The brightness of a color is just the total of the red, green, and blue color values. So if we were to say color red times equals brightness, color green, color blue. You could just as easily say color.rgb times equals brightness. You're allowed to do that. As I've mentioned before, swizzling components of vectors to access multiple members at the same time. It saves you a little bit of time as the programmer. It makes your code a little bit neater. It's apparently slightly faster for the computer to process as well. So over here, if we set brightness to 1, 1 is the multiplicative identity. So you can multiply anything by it and it'll come out the same as it started. You could multiply it by 0 instead, which would turn everything black. Someone is banging on something with a hammer. Multiplying anything by 0 is 0. The color value of 0, 0, 0 is black. If you wanted to darken it slightly, without going fully 0, you can. That is 0.5. This is going to be 0.25, which is going to be very dark. If you wanted to brighten it, you could multiply it by a value greater than 1. So 2. And again, if you do that, you might want to watch the bound. That looks really washed out. If you do that, you might want to watch the bounds of this so that it never goes higher than 1. I don't really care. If you multiply it by a big enough number, let's say 10, then everything will be set to everything that is non-zero will be white. If you do that, then it's going to be really yellow. That looks really bizarre. I don't even know what's going on there. Anyway, let's see what happens if I put these all together. It's gonna look like something, I'm sure. Am I actually using the, I am. So these are uniforms. You can use them to customize the behavior of your shader during runtime while the game is playing. And you can use that for whatever cool things you want. In the next shader videos, I am thinking I'm going to talk about other types of image processing, for example, blurring, mosaic filtering, posterization. I would say color inversion, except you can probably guess what you would do to achieve color inversion already, given what I've shown off in these videos. So I guess I'll make that a homework assignment or something. I'm probably going to stick with 2D shader things, at least for a little while, before I get onto things like 3D lighting and that kind of stuff. Just so that I don't dump a bunch of information on everyone's head at once. But definitely if you have a preference for something that you want to see when it comes to shaders, let me know. I guess the exception would be things like cell shading, toon shading, because that relies on a combination of a couple things that I have yet to talk about, and I'd like to save those for later. I need to go over the building blocks first. Anyway, my name is Michael. I like wizards and dragons and making games. I have a Patreon, so if you want to chip in towards making these videos, the links to that are in all the usual places. Otherwise, I try to post about 2 of these things a week, both for 3D game dev and not 3D game dev. I haven't actually posted a 3D video in a while. Most likely the next 3D video I make is going to be about lighting, and hopefully by the time I finish with that, I'll have something ready to go when it comes to collisions in native GML. Anyway, I hope you found that useful. I know there was a bit more tangible stuff going on in this video than in the last one, and I will see you all later. Special thanks to Indie Punch and Zenith for supporting these videos. If you want your name in the credits and to get these things a day early and some other fun stuff, head over to the Patreon page in the video description. Join the fun.